Good morning. Um, so we're going to be introducing our last target today. This is target 4. Um, it's actually probably one of the easier targets. Actually, it's probably the easiest target out of any one of this during this distance learning. So even if you struggled with some of the other ones, follow along with what we're doing here today. I think it's something you'll be able to do. So long story short, we are going to learn about the circuit. So this is something we've done in the past. I'm hoping this all looks pretty darn familiar to you. And what we're going to be doing here is we're going to be translating a lot of the things that we did in our circuits, and we're going to be translating them to what language and math is normally used. If you go off and become an electrical engineer, none of your electrical engineer buddies are going to be drawing arrow tails and color coding things. Instead, they're going to be using other symbols, other notations, other math. And we're going to translate that. And to do that, we are going to be using some of our graphing skills and some of our interpretations of things. So there's a reason why this one came after that, because in order for me to really teach you how some of this stuff works, we have to actually know how to graph some things. So let's start here by reminding ourselves of what this all means. Here we have a battery pack. That battery pack is supplying some sort of pressure difference. Red to blue is how we describe this. This is a 4-step pressure difference. So we remember we have different numbers of steps. This is a 4-step going from red to blue. Across this round bulb, we get 2 steps, red to yellow. And then across this other round bulb, we get another 2 steps, red to yellow. These are equally stepped because they are the same resistance. So 2 steps, that is 3 arrow tails. Same thing for the long bulb. We still get it split into 2 steps, but because the long bulb is higher resistance, we do not get as much current flow. 2 steps here only gets us 1 arrow. So we expect to see more current flow in the round bulb than in the long bulb. Finally, what happens when you have one round and one long? We get a bigger drop in current across the long bulb. See, this red to orange is only a 1-step, and this orange to blue is 3 steps. Both of those, they are in a steady state, so we know that the same amount of current flows into this orange wire and out of this orange wire. But because the long bulb has a higher resistance, we get a larger buildup of pressure across the long bulb to make this happen. So this is how we would have described this in our last unit. And what I want to do today is I want to show you what this looks like in the more common usage, right? What are the actual terms we use instead of pressure drops? What are the actual terms we use instead of red and orange? So to do this, we're going to be taking a moment. We are going to be looking at Falstad. So Falstad is purely a simulation. I would have loved to actually been able to go through and show you the real thing, but this is the best we got right now. So looking over here at Falstad, I have the same 3 circuits set up. So over here on the left, I have, this is the 2 round bulbs, 2 long bulbs, and then round and long, just like right here. And so what we're going to be doing is we're going to be looking at what Falstad, just how Falstad describes these circuits, and then compare them to how we describe the circuits. So the first thing I want to look at is I want to look at our battery packs. These this red to blue drop. What does Falstad call that? So looking here at Falstad, if I scroll over and I look at the battery pack and I mouse over it and it turns blue, you'll see that things show up in the bottom corner. And I get 3 numbers there. I actually don't care about the bottom one at all for any of this. We're only going to be paying attention to those top 2 numbers. Specifically right now, I want to look at VD. So you'll notice that VD is the same here, it's the same here, it's the same here. VD stands for voltage. drop. Now, voltage drop is a fancy term for this is a fancy term for the pressure difference. So voltage drop is the amount of difference here between the red and the blue. Now, before we would have called this 4 steps, but when we look at Falstad, the way Falstad describes it is 4.5 volts. So what we were calling 4 steps before, Falstad calls 4.5 volts. And actually, to be specific, remember this battery pack is made out of 3 batteries. Each battery is 1.5 volts. Each battery provides 1.5 volts of pressure difference. So going from red to blue, we get 4.5 volts of pressure difference total. And that's the same for all of these. So let's go ahead and see what it tells us about this red to yellow. I'm going to go ahead and look at the red to yellow here. I'll look at the red to yellow here, and then we'll look at the red to orange and see how it compares. So here, I'm going to go ahead. Okay. So here, when we look at red to yellow, we look at VD, we get 2.25. That is exactly half of our 4.5. So just like in our drawings where we went from red to yellow and then yellow to blue, we're getting half of the pressure drop here and half of the pressure drop here, 2.25 again. Over here in this guy, 2.25 pressure drop, 2.25 pressure drop. Again, those add up to 4.5. We're still getting our 4 steps. We're still getting our 4.5 volts. Here's where things start to get different. Here, I only see about 1/4 of a volt dropped. So this is in millivolts at this point. So that means it's not 287, it's 0.287. So a little bit more than 1/4 of a volt. But down here, I get almost the entire pressure drop, 4.2, all the rest of that pressure drop. We get a significantly larger pressure drop here. Now, I'm going to be honest, that's not exactly what I would have expected mathematically. There's a decent chance that I messed up when I programmed this for the long bulb, but we'll just call it good for right now. It's going to have to cut it because I can't change it right now. But overall, what we see is in each of these cases, there is overall a 4.5 volt drop. We've always called that 4 steps. So now let's look at the arrow tails. So back here in our drawings, we would have drawn this as 3 arrow tails and 1 arrow tail. And this represents the amount of current flowing. How much actual charge is flowing through this? So let's go back and look at our Falstad here. In this little simulation, what we see here is now we look at the I. I stands for current. So here at the I, we see 114.7. Now that's in milliamps, so you actually should put a decimal point in front of that. It's 0.114 amps. That is the unit that we use for current flow. So you will never see someone drawing arrow tails on some diagrams, but you will see them say 0.114 amps or 114.7 milliamps. We expect this one to be about 3 times bigger than this one. And sure enough, it is. Here we get 0.32 amps or 32 milliamps. Because the long bulb has a larger resistance, we are getting less current flow. This one should be the same because it's still just the same long bulb. It's just the long bulb. It's just the long bulb. But here, this one should be different. So we saw here, this one is 50. It's a little bit higher. And it's a little bit higher because going back to our diagram over here, remember we get a larger voltage drop here. So here we are getting a larger voltage drop through we're getting a larger voltage drop through the long bulb. It's no longer 2 steps. It's 3 steps. So we get a larger current flow. Conversely, compared to the round bulb, which was 114 milliamps, we are getting about half of that. Well, here this was 2 step. Here this is only 1 step. Because this is only a 1 step difference, we only get half as much current flow. So these 2 top numbers are the only ones I want you to pay attention to for the time being, I and V, where I tells us the current flow, the voltage drop, those it tells us the current flow, those arrow tails, right? The number of arrows and arrow tails we would draw. We're just going to use a number with amps next to it instead of drawing an arrow. Finally, the voltage drop over the whole thing in all of these is 4.5 volts. That corresponds to a red to blue. That comes from our 3 batteries. You can imagine if we added or removed batteries, we would make that voltage drop bigger or smaller. But the voltage drop we can also see around each of our bulbs. We see in this one, the vast majority of our voltage drop comes down here across the long bulb. And we described that back when we were doing our experiments because the long bulb had a higher resistance, so we get a larger voltage drop across it. In our next video, we're going to actually put together a lab, and we're going to see how all of these things are related. But for right now, I just wanted to give you this chance to try to learn how to translate from one to the other. All right, everyone. Thank you very much. Have a nice day.